A galaxy far, far away in our living rooms, lightsabers. The very word evokes excitement, danger, and the allure of a galaxy far, far away. These glowing blades of plasma housed in a hilt have become a symbol of the Star Wars universe. They are not just weapons, they are a representation of the eternal struggle between good and evil, the Jedi and the Sith. Since their debut in Star Wars, lightsabers have captured our imaginations. From the first moment we saw them on screen, we were hooked. The hum of the blade, the clash of colors, and the epic duels have all contributed to their legendary status. Fans around the world have embraced lightsabers, creating replicas, engaging in cosplay, and even choreographing their own lightsaber battles. They are elegant weapons for a more civilized age. Unlike the blasters and other firearms seen in the Star Wars universe, lightsabers require skill, training, and a deep connection to the Force. They harken back to the days of knights and samurai where honor and combat prowess were paramount. But could we ever build one? The idea of creating a real, functional lightsaber has fascinated scientists and engineers for decades. The challenge lies in the technology and the materials required to produce a blade of pure energy that can be controlled and wielded like a sword. Could this iconic weapon exist beyond the silver screen? While we've seen impressive replicas and special effects, the dream of a real lightsaber remains elusive. However, advancements in laser technology and plasma research bring us closer to this dream than ever before. The answer, like many things in science, is complicated. It involves understanding the principles of energy, containment, and the limitations of our current technology. Scientists are exploring various approaches, from high-powered lasers to plasma arcs, each with its own set of challenges and potential breakthroughs. It involves delving into the realms of physics, engineering, and our current understanding of the universe. The quest to build a lightsaber is not just about creating a weapon, it's about pushing the boundaries of what is possible, inspiring innovation, and igniting the imaginations of future generations. Join me as we explore the tantalizing possibility of bringing lightsabers from science fiction to science fact. Together, we'll journey through the latest research, meet the brilliant minds working on this challenge, and discover how close we are to making this dream a reality. The future of lightsabers is bright, and the adventure is just beginning. Science fact or fiction? Can we build a lightsaber? This question has fascinated both scientists and fans of science fiction for decades. The idea of wielding a blade made of pure energy, capable of cutting through almost anything, is undeniably captivating. The short answer? Not yet. Despite our advances in technology, we haven't quite cracked the code on how to create a real, functional lightsaber. The long answer? Well, it's a bit more nuanced. While we haven't achieved the exact specifications of a lightsaber as seen in Star Wars, there are some promising developments in the field of plasma and laser technology that could bring us closer to this dream. Lightsabers, as depicted in Star Wars, possess some characteristics that defy our current scientific understanding. For instance, the blade is made of pure energy, yet it stops at a certain point and doesn't extend indefinitely. The blade, made of pure energy, somehow stops at a certain point. This is a significant challenge because, according to our current understanding of light and energy, such a phenomenon is impossible. Light and energy beams typically continue until they hit an obstacle or dissipate. This is something our current understanding of light and energy says is impossible. However, don't lose hope. Scientists are constantly pushing the boundaries of what we know and understand. With ongoing research in fields like plasma physics and high-energy lasers, we might one day find a way to create a controlled energy blade. Science fiction often inspires science fact. Many of the technologies we take for granted today, like cell phones and tablets, were once the stuff of science fiction. The same could be true for lightsabers. By examining the basic principles of a lightsaber, we can explore existing technologies and research that might one day make this futuristic weapon a reality. For example, researchers are developing plasma-based tools and high-energy laser systems that could potentially be adapted for use in a lightsaber-like device. While we may not be there yet, the journey of scientific discovery is full of surprises, and who knows what the future holds. Unlocking the secrets of the Force, the physics of a lightsaber. Let's break down the core components of a lightsaber. At first glance, a lightsaber might seem like pure science fiction, but let's delve deeper into the science that could potentially make it a reality. Firstly, it needs a blade of concentrated energy that can cut through materials like butter. This blade is often depicted as a plasma beam, which is a state of matter similar to gas but with its particles ionized, making it electrically conductive. Secondly, this blade needs to be contained within a specific length, unlike any form of energy we know. This containment could theoretically be achieved using magnetic fields to shape and hold the plasma in place, creating a stable sword-like structure. Thirdly, it needs a power source capable of generating and sustaining this immense energy output. The power requirements for such a device would be astronomical, necessitating a compact yet incredibly powerful energy source, possibly a miniaturized fusion reactor, or an advanced form of battery technology. Each of these components presents a significant scientific hurdle. The creation of a stable plasma blade, the magnetic containment field, and the high-energy power source are all areas that push the boundaries of our current technological capabilities. Overcoming these hurdles would require groundbreaking advancements in our understanding of physics, particularly in the fields of energy manipulation and containment. Scientists would need to develop new materials and technologies to handle the extreme conditions required for a lightsaber to function. This includes heat-resistant materials for the hilt and advanced cooling systems to prevent overheating. Additionally, the control mechanisms for such a device would need to be incredibly sophisticated. The user would need to be able to activate and deactivate the blade instantaneously, control its length and intensity, and ensure it remains stable during use. This would likely involve advanced electronics and possibly even some form of artificial intelligence to assist with the precise control required. While the concept of a lightsaber remains firmly in the realm of science fiction for now, the exploration of its physics can inspire real-world technological advancements. By pushing the boundaries of what we believe is possible, we can drive innovation and potentially unlock new scientific discoveries that could benefit various fields, from energy production to materials science. The journey to create a lightsaber is not just about building a weapon, it's about expanding our understanding of the universe and harnessing the incredible power of science and technology. Who knows what other amazing inventions and discoveries await us on this path? Lasers and plasma are best bets for a real-life lightsaber. Currently, the two most promising areas of research that could lead to a real-life lightsaber are lasers and plasma. Lasers are highly focused beams of light capable of generating intense heat. We already use lasers for cutting and engraving in various industries. Plasma, on the other hand, is a superheated state of matter. Often referred to as the fourth state of matter, plasma is essentially ionized gas with incredible energy. Plasma cutters are already used in industrial settings for cutting thick metals. Here's where things get tricky. Both lasers and plasma beams in their current form continue expanding indefinitely. They don't simply stop like a lightsaber blade. Containing either of these energy forms within a short, sword-like length is a challenge we haven't yet overcome. Some theories suggest using magnetic fields to contain plasma, similar to how we are exploring nuclear fusion. However, the energy requirements and complexity of such a system are beyond our current technological capabilities. Another significant challenge is the power source. Lightsabers require an immense amount of energy to function. Even our most powerful batteries are woefully inadequate to power a device like a lightsaber, even for a short period. We need a new type of energy source, something compact yet capable of generating and sustaining enormous amounts of power. Perhaps advancements in fusion power or other revolutionary energy technologies could hold the key. Let's not forget another iconic characteristic of lightsabers: their ability to clash against each other. This implies that the energy blades have mass and can interact with each other, something that contradicts our understanding of light and plasma. Creating energy blades that can collide and repel each other would require a fundamental breakthrough in physics. We would need to discover new ways to manipulate energy and matter, potentially rewriting our understanding of the universe. While the challenges of building a real lightsaber are immense, they are not insurmountable. The pursuit of such a fantastical technology can lead to unexpected discoveries and advancements in other fields. Remember, the impossible often merely reflects the limits of our current knowledge. The quest for a real lightsaber embodies the spirit of scientific exploration. It's about pushing the boundaries of what we know and daring to dream of what might be possible. So, will we ever have real lightsabers? It's impossible to say for sure. However, history has taught us that human ingenuity knows no bounds. What seems like science fiction today could become reality tomorrow. Perhaps one day, in a galaxy not so far away, lightsabers will transition from the realm of fantasy to the tools of reality. Until then, the pursuit of this iconic weapon will continue to inspire scientists, engineers, and dreamers alike. May the Force be with them.